Hello students. So today we are going to do some physics numericals. Okay. So first question is, work function of metal is 1.6 into 10 raised to minus 19 joule and its surface is illuminated by a light of wavelength 6400 angstrom. Okay. Find maximum kinetic energy of emitted photoelectrons. So we know the formula, that is total energy of the photons, okay, is given by the work function. We write it as W naught or phi naught, okay, plus the kinetic energy, maximum kinetic energy. Okay, this can be written as phi naught plus, some of the books it is written like this. Okay, this is the work function and this is the maximum kinetic energy, okay, of emitted photoelectrons. So here what is given, work function of a metal is 1.6 into 10 raised to minus 19 joule. So we'll write first what is given. So work function is given. Okay, its surface is illuminated by a light of wavelength 6400 angstrom. This you have to convert it into meters. So 6400 into 10 raised to minus 10 meter. Okay, so how energy is given? H nu, right? Now here frequency is there, but here frequency is not given. So we have to make use of the wavelength. Okay. So how frequency is written in terms of wavelength? C upon lambda. So maximum kinetic energy is Hc lambda minus phi. Okay. Value of H, that is Planck's constant, is 6.63 into 10 raised to minus 34. Value of C, speed of light, 3 into 10 raised to 8 upon lambda is 10 minus the work function. Okay, so you have to first calculate this thing. Okay, so I'll write 6.63 into 3 upon 64. Okay, this 0 I'll take it as 10 raised to 2. So here we have minus 34 plus 8. This is plus 10 when you take it in the numerator, and this is 10 raised to 2, correct? So when it comes in the numerator, it becomes minus 2. This is 3 3s are 9, 19.8, 64 into 10 raised to, this is 10 minus 2, 8, 8, 8, 16. So 34 minus 16, 18 minus 18. Okay. So we'll remove this point. If you remove this point, you have to multiply here 100, right? I'll divide this. 64 3s are 1s are. So for point I've put 0, but 50 is less than 64. So yeah, 500 discloses 7s are. Okay. So 31.07 into 10 raised to minus 18, and 1 0 I'll take in the numerator, that is 10. Okay, So it will be -1. This is 10. Okay. Why I did this? Okay. -18 -1, because I want here 19 is there, and here also I want 19, because we have to subtract this. Okay, so power should be equal. Okay, so this 10 I can take here, that is point will shift this side. 3.107 into 10 raised to -19 minus 10 raised to -19. So this is 3.107 minus 1.6 into 10 raised to -19. 1.507 into 10 raised to -19. So this is the answer. This is kinetic energy, which is maximum. It is in joules. Okay. Next question. The coefficient of mutual inductance when flux changes by 2 into 10 raised to -2 Weber and current changes by 0.01 ampere is. The coefficient of mutual inductance we have to find. Now here the change in flux is given and change in current is given. Okay, so you can use the formula m di by dt equal to d phi by dt. So this is change in flux and this is change in current. Okay, we have to find m. So di by dt is given, that is 0.01 m, and d phi by dt is given, which is 2 into 10 raised to -2 Weber. Okay, so this is 0.01 10 raised to -2. So 2 into 10 raised to -2 upon 0.01. So how you can write 0.01? This is nothing but 1 upon 100, right? So this 100 comes in the numerator. So 2 into 10 raised to -2 into 10 raised to 2. So this is 2, and mutual inductance unit is Henry. 2 Henry. Okay. Next question. A uniformly charged conducting sphere 2.4 meter in diameter has a surface charge density of 80 microcoulomb. This is okay, microcoulomb per meter square. Calculate charge on the sphere, total electric flux passing through the sphere. Okay. Now, if you remember, this is the sphere, and when we have to calculate the this thing electric field, okay, then we take a Gaussian surface, right? So the radius of this sphere is suppose r, okay, then its surface charge density, that is surface charge density, how it is given, q upon area, right? Total charge upon the area. So in this case, surface charge density is given by sigma is equal to that is q upon 4 pi r square. Okay, so let's write what is given. So what is given? Diameter is given 2.4. So this radius, I'll take it as capital R. Okay, meter. So radius is divided by 2 you have to do. This is 1.2 meter. Okay, then surface charge density, that is sigma, is given by 80 microcoulomb per meter square. So this you have to change, that is we have to make it coulomb. So this is micro is given. So this is 80 into 10 raised to minus 6 coulomb per meter square. Okay. So let's use this formula. First one we have to find charge on the sphere. So sigma is equal to q upon 4 pi r square. Okay. Q we have to find. So Q becomes sigma into 4 pi r square. Okay. Sigma is 80 into 10 raised to minus 6. 4 into pi you can take 3.14 and r square is 1.2 the whole square. 8 4s are 32 and 0 is there, so it is 10. So I'll take it as minus 6 plus 1. So it becomes minus 5. 12 square is 144 and then you have to put the point. Okay, now you can multiply. So this is 12, 5, 4, point is 4.5. Okay, then you have to multiply this. So I'll take 4.52. Okay, so 14464 point is up to, I took only 4.52, right? So here into 10 raised to minus 5. Okay, so if I have to shift this point, I can do one thing. This is divided by 100. So divide by 1000, divide by 10,000. So two places I have shifted. So minus 5 plus 2. So it will be minus 3. Okay, this is a charge. So it is coulomb. Okay. Second thing you have to find is total electric flux passing through the sphere. So flux is given by Q upon epsilon naught. Okay. Q is 1.44. I'll take 3 upon epsilon naught is 8 point. This will be given into 10 raised to minus 2. So I'll remove these points. So it will be 100. 1000. Okay. This is plus 2. This we have to divide. Okay. So 0.0 ones are Okay, so this comes 6. 0.16 into 10 raised to 9. Okay, and this is the value, not value, the unit you can write by using the units of this and the coulomb, that is of charge. Okay, so it comes to Newton per coulomb meter square. Okay, next question. The length of a solenoid is 50 centimeter. Okay, how many turns will produce a magnetic field 3.14 into 10 raised to minus 3 Tesla inside the solenoid of current of 1 ampere is passed through it. Okay, so here length of the solenoid is given 50 centimeter. This you have to convert it to meters. Okay. Magnetic field is given, so magnetic field is given by B, Tesla, and current is given 1 ampere. Okay, now first you have to find the number of turns. So using magnetic field of solenoid, okay, magnetic field is given by B is equal to mu naught into Ni. Mu naught is 4 pi into 10 raised to minus 7 N into 1. Okay, B is given, so I'll write it here, minus 3. Okay, we want N, so this thing comes here, 4 into 3.14 into 10 raised to minus 7. Okay, so 1 by 4 into 10 raised to minus 3 plus 7, which is 4. Okay, 1 by 4 is what? If you take 4 and divide to 1, so 4 2 za and 4 5 za, right? 0.25 it is into 10 raised to 4. So this you can write by 1, 2, 3, 4. So 2500 tons. Okay. Now why length is given? Because this is for 1 ton. So we want a total number of tons. That is, for this much of length, how many tons will be there? So total number of tons is given by this tons into the length. Okay. This is 1250. This is 10 raised to 2, 10 raised to minus 2. So 1250. Okay.